Hello, my name is Dr. Terri Norton, and I am going to talk to you today about construction engineering. First, let me tell you a little bit about myself. I am the Associate Professor of Architectural and Construction Engineering within the Durham School of Architectural Engineering and Construction. I am also the Construction Engineering Program Coordinator. My degrees are in the area of civil engineering, so I have a Bachelor of Science in Civil Engineering from Florida State University, go Noles, and a Master's and PhD from Florida A&M University. Which, interestingly enough, their College of Engineering is set up similar to what we have here in Nebraska. It's the FAMU FSU College of Engineering, where there are two universities sharing one college. My degree's in civil engineering, but I have a specialty in structural dynamics. So before coming here to Nebraska, I worked at the Aerospace Corporation in their structural dynamics department from the Vehicle Systems Division out in El Segundo, California. Now that I'm here in Nebraska, my research interests are varied, or more specifically, they fall in the area of natural hazard assessment, the effects of dynamic loads on civil structures, sustainable construction, and disaster recovery. I'll give you a preview of some of the projects that are going on or recently happened in my research group. I manage the Structural Dynamics Research Group, and my students that work for me work on projects related to natural hazard assessments and structural dynamics. One of those projects is this comparative study of base isolated structures using a cost-based approach. What it basically was, or the objectives were to evaluate the structural performance of building systems that are uncontrolled and controlled by base isolators, and then do a comparative study based on the damage performance and the cost. And so with this, we assessed a building based on some ground motion, which can be an earthquake load, looked at the structural response, and then compared that to what we call fragility curves, which basically evaluates the amount of potential damage based on some performance index. Another project that's going on in my research group is looking at deflections of phase-constructed steel girder bridges. This happens to be a project that's funded by the Nebraska Department of Roads. With phase-constructed bridges, in some cases there are issues with differential elevations between phases. So one phase is constructed, and then before the second phase is connected to the first phase, sometimes there's some differential elevations between those two bridge decks. And so in order to understand what causes that differential elevation and how we connect those two decks with minimal construction costs and time, it's something that the Department of Roads is really interested in understanding. And so this is a project we started looking at an existing bridge under construction here in the Bellevue area. It's called the Plattsmouth Bridge Project. And this bridge project is actually finishing up this summer. And so this was one of the examples of research that's going on in my research group. Another project, as I said, I'm interested in natural hazards and their effects on civil structures. I have a project that's funded by the U.S. Geological Society, in which we're looking at a scenario or as a simulated tsunami event that happens along the California coast, and looking at the effects that that tsunami event will have on port facilities, the Port of Long Beach and the Port of Los Angeles, and how that will affect their business, interruption, import and export, what type of disaster debris that may be generated by this tsunami event, and how to manage that type of disaster. If there's a lot of generated debris, what do we do with those debris items? How do we get the port facilities back up to operational? And then we also looked at some other areas along the southern coast of California as well. Another project, as I mentioned, looking at disasters and their effects on civil structures, understanding when a disaster event happens, how do communities or how do areas recover based on the size of the event and the amount of debris that's generated. So one of my projects is looking at sustainable disaster debris management by understanding the amount of debris that's generated, what types of debris that's generated, and determining if there's a possibility to recycle and reuse that debris so that it can speed up the recovery process, whether it's recycle and reuse for the construction of temporary shelters or immediate shelter, or if there's ways to manage it logistically so that we can speed up the recovery process. And so that's one of the other projects I'm interested in and researching within my research group. Now, as I mentioned earlier, I'm a part of the Durham School. The Durham School's motto is 3-2-1, which means 3 programs, 2 campuses, 1 school. The 3 programs that make up the Durham School are architectural engineering, construction engineering, and construction management. We offer these programs on 2 campuses. For construction engineering, and construction management, those are offered both on the Lincoln campus and on the Omaha campus. Lincoln campus, we're located at Nebraska Hall, or the Offmer building, and then on the Omaha campus, we're located at the Peter Keewood Institute. For architectural engineering, that is only offered in Omaha. Now we have these 3 programs, 2 campuses, 1 school, but one of the programs I'm going to focus on is construction engineering. So, construction engineering can be generally defined as a civil discipline that blends the fundamental principles of engineering with new and emerging technologies for design, for planning, for the management of infrastructure systems. These infrastructure systems can be buildings, bridges, dams, tunnels, what have you. Within this construction engineering program, many have to decide, well, how do you determine whether you want to do construction engineering as compared to construction management, because we offer both of those within the Durham School. So when thinking about construction, how do you decide between construction engineering and construction management? Well, as you can see here, our general makeups for the 2 programs in terms of the GPA requirement and the grade requirements are similar. However, for construction engineering, you have to take advanced math courses like calculus 1, 2, and 3, differential equations, probability and statistics. You also have those engineering courses and design courses, which are differ from the management program. In management is mostly business oriented, so you learn a lot about methods and procedures and planning and scheduling. But for the engineering discipline, you learn about the construction project from start to finish. So you'll be able to understand the design considerations in addition to on-site construction practice and scheduling. In addition, as a construction engineer, you're able to sit the PE exam, which allows you to become a professional engineer in the field. Give you an idea what the first year classes look like. This provides our Omaha first year schedule. As you can see, you take your foundation courses within the first year. You have your chemistry, your calculus, your physics. You also have your intro to construction engineering, so you'll learn a little bit more about what it means to be a construction engineer. And then you also have your design graphics course. On the Lincoln campus, the same basic classes. The course numbering is a little bit different, but you still have those foundation courses, your chemistry, your intro calculus 1 and 2, your physics, your intro to construction engineering. Please note, after your first and second year within the construction engineering program, you must apply for professional admissions. So once you have about 60 hours of degree credit hours, you must apply for professional admissions to the construction engineering program. And that helps us make sure that you have your prerequisites necessary to move on to those junior level courses. A lot of our students, once finishing our degree program in construction engineering, they find jobs in the areas of heavy civil construction, life cycle cost assessment, process design, and simulations. And these are some of the companies that hire construction engineers. Coming out of the Durham School, our students have a job placement rate of about 75% or higher, and that's been our statistics for the last 3 or 4 years. We also encourage that students take internships, so if you have the opportunity to work for a company part-time over the summer, we encourage you to do that because that will only enhance your credentials once you graduate. In addition to your coursework, we also encourage our students to get involved. There are several student groups on campus. There are some that are construction emphasis groups, like AGC, the Associated General Contractors, SCSC, Society of Specialty Contractors, the National Association of Home Builders, NAHB, Sigma Lambda Chi, which is our honorary society for construction engineering. But you can also get involved in other engineering groups. ASCE is a good group. I advise the Earthquake Engineering Research Institute and the National Society of Black Engineers. Other groups are EWB, Engineers Without Borders, Society of Women Engineers, and the Durham School also has their own ambassadors program. So if you want to take on a leadership role within school, that's also something you can consider doing. By getting involved, it only enhances your credentials, your resume, enhances your leadership skill, your team building skills, and make you more marketable once you graduate. As I mentioned, I do advise some student groups, and EERI is one of those, the Earthquake Engineering Research Institute. I'm very proud of this group because it brings in your engineering and construction knowledge. We compete annually in an annual seismic design competition. In this competition, our students are judged on their architectural aesthetics, their revenue generated by the structure that they build and the rentable space, and also the seismic performance. We have these 5-foot tall balsa wood structures that we put on a shake table and we shake them with earthquake loads and try to understand if our design will perform good or bad under certain seismic conditions. And we've been competing in this competition since 2009, and the students have really enjoyed it. So I've had students from architectural engineering, construction engineering, civil engineering, and even electronics engineering participate on this team. So that may be something for you to think about. In addition to our undergraduate programs, we do offer graduate degree programs. So if you're interested in specializing in something that you learned in your undergraduate program of study, you may consider going to graduate school. We offer a Master's of Engineering and Construction, a Master's of Science in Construction Engineering and Management, and a PhD in Construction Engineering and Management. Our master's options, you have thesis or non-thesis, whether you want to do a project-based Master's of Science or a thesis-based Master of Science, those are up to you, and you can check that out on the Graduate Studies website. So if you'd like to know more about the Durham School and our programs, you can check out our website. It's listed here as engineering.unl.edu/Durham School. Learn more about all of our programs in addition to our construction engineering programs. Learn about the opportunities that we have online, how to get connected with other students in the school, and how to learn more about internship opportunities, admissions and advising. All those are provided on our website. And if you have questions for me, feel free to contact me at tnorton3@unl.edu. Thanks, everybody. Have a good day.